In this video, we're going to go over how to name acids. And acids are actually a type of covalent compound. They're covalent because all the elements that are bonded in this compound are non-metal elements. So let's actually take a look at the bottom right here of this intro slide. I want you to notice that all of the chemical formulas right here for these acids, notice what they begin with. They begin with H's, and that's actually what is characteristic about acids. If you dissolve an acid in water, it will actually release these hydrogen ions, and these hydrogen ions are what are responsible for the properties of acids, like their corrosive tendency or their sour taste. It's due to these hydrogens. Okay, so all of them begin with hydrogens in their chemical formula, and for their names, you actually write the word acid in it. That's something else that you should notice. Okay, so two things that we're actually going to start off with. There's H in the front of the chemical formula, and when we're naming them, they actually have the word acid in it. Now let's go over some of the rules. So these are the rules that you're going to need to know, and we're just gonna kind of go over them right now and then go over some examples. Just know that at the beginning, the rules will not make sense until you actually do some examples. Um, so we have binary acid naming, and in binary acid naming, I want you to take a look right here. We have first off the chemical formula and the actual naming of it, of that chemical formula. In the chemical formula, I want you to notice that it begins with an H, but this part right here, the X, is more important. That X is supposed to represent an ion here, okay? And this ion, it just happens to be an ion that ends with IDE, okay? The name of the ion ends in IDE. And if that happens to be the case, you're going to use this naming convention, hydroblankic acid, right? So binary acids are just acids that have an ion where it's a monatomic ion. So it's just going to be something like F minus, Cl minus, Br minus, or I minus. For oxyacids, we're actually looking pretty much at the same thing. We're looking at a chemical formula here and a naming convention. For the chemical formula, however, the X is going to always be a polyatomic ion. So we're going to have to know the names of polyatomic ions. In this first rule, that X is supposed to represent an ion that begins with hypo and ends in ite. So if your ion name begins with hypo and ends in ite, then you're going to use this naming rule. It's going to be hypoblankous acid. Right? Here's another oxyacid. So again, it begins with an H, but the ion that follows it is more important. This polyatomic ion is an ion that ends in ite. So if your ion name ends in ITE, then you use this naming convention right here, blankous acid. Here's another one, another rule. It begins with H because it's an acid, and then it's followed by this ion, and that polyatomic ion is going to be a ion that ends in 8. Okay, so if it ends in 8, then you're going to use this naming convention right here, blankic acid. And lastly, we have this chemical formula. It begins with H again because it's an acid. However, it's followed by a polyatomic ion. And for this polyatomic ion, it's an ion that begins with per, but it ends in 8 as well. If this is the name of the ion, then we're going to use this naming convention right here, perblankic acid. Okay, so kind of makes no sense right now because we're not doing any examples. So let's just start doing some examples so it does make a little bit more sense. So here we go. We're naming acids. Here's our first example. It is an acid because it begins with H. However, the more important part is what is the name of that ion right there. So we're going to revisit our old resource sheet right here. What is F? F is right here, so the name of it is fluoride. Okay, fluoride. That's important because it ends in "ide." Okay, that's really important. So if we look at our rules again, which rule do we use if it ends in "ide"? It's going to be this first one right here. All right, we're going to use this first rule because it ends in "ide." So we know here that we're going to use hydroblankic acid. And we're actually going to keep the base here. The base is going to be fluor from fluoride. So it's going to become hydrofluoric acid. If you take a look at the final answer, it's correct. All right. So that's kind of how you use the rules here. So hopefully you kind of get the idea. I do want to point out that some of the rules, they're actually not like perfect. So please make sure you do watch the entire video. Here's our second example, and this is actually the one that I want you to know about where the rule isn't quite perfect. So again, this is an acid because it begins with H. However, the more important part is the name of this thing right here. What's the name of this polyatomic ion? If you revisit our old resource, SO4 is going to be found right here. SO4, it's called sulfate. Okay, sulfate. So that's important because when we look at um, the rule for sulfate, which ends in ate, we can decide the name of it. So we're using this rule right here. Okay, so it's an ion ending in ate, so we're using blankic acid. And here's the tricky part. What is the base? What is the base that we're going to put in? You think we're going to put in sulf and just sulf, but it's actually not sulfic acid. You've actually heard of this word before if you've done our labs. It's actually supposed to be sulfuric acid. Sulfuric acid. So this is where I'm saying how the rule isn't quite perfect. There are some cases where you just happen to have to know what the name kind of generally is. The rule is not perfect here, but it kind of leads you to the final answer. Okay? The final answer here is sulfuric acid. All right, let's take a look at example 3. So this is an acid right here because it begins with H, but the more important part is what is the name of that ion right there. Okay, so we're going to look at our common ion table. I is right here. It's iodide. Iodide. That's important to know because we're going to need to know the ending of our ion, which is "ide." So let's look at the rules again. If it ends in "ide," we are going to use this first rule. Hydroblankic acid. Hydroblankic acid. Okay. So what we're going to put in this blank part is the base for iodide. There it is. Hydroiodic acid. Hydroiodic acid. Let's check our final answer. It is hydroiodic acid. Okay, let's go over 2 more examples. Here we have an acid again because it begins with H. However, this part is the more important part, NO2. What is the name of that ion? It's a polyatomic ion, by the way. NO2. NO2. This is important here. It's nitrite. Okay, it's nitrite, not nitrate. So if it's nitrite, we're going to have to consider that naming where it ends in ITE, because in our rules, the difference between ITE and ATE gives you a completely different name. So if it ends in ITE, we're going to use this rule right here. Blankous acid. Okay, blankous acid. Blankous acid. And we're going to use a base right here. The base is nitr without the ITE. Let me go ahead and push this away. Nitrous acid. Nitrous acid. And if we check our final answer, it is nitrous acid. Okay. We're going to go over one last example, one final example. here it is, HOCl. Notice that it does have an H in the front, so this is an acid. But the more important part is the OCl part. What is the name of that polyatomic ion? Let's go ahead and look at our reference sheet. OCl is right here. It's called hypochlorite. Hypochlorite. And that's going to be important. So let me go ahead and write it down first. Hypochlorite. And for this one, it actually ends in ITE, but it also begins with hypo. Okay, that's going to be important because when we look at our naming rules, it's actually going to correspond to this right here. Okay, so we have an ion that begins with hypo and ends in ite. So our name is going to be actually hypo blank acid. And the base word that we're going to use for this is in hypochlorite. It's going to be the chlor part. So we're going to write that in. Hypochlorous acid. That's going to be our chemical name. Let's go ahead and check the final answer though. And there it is. Okay. So there was an imperfect naming that we did in our second example with sulfuric acid. Just know that some of these naming rules aren't perfect. I'll just tell you which one they are right now. It's going to be sulfuric acid. It's not sulfic acid. Sulfurous acid, it's not going to be sulfus acid. And the last one is phosphoric acid. It's not going to be phosphic acid. Okay, so I'll say them one more time since the rules are imperfect for those three acids. It's sulfuric acid, sulfurous acid, and phosphoric acid. Those are the three acid names that are not quite fitting the rules that we have for naming acids. They're just a little bit different. However, you should still be able to use the rules to kind of figure out the name.